All right, the last section for Chapter 9 is going to involve lab testing and methodologies. So we've talked about this throughout the chapter, but here is a nice summary for hyper, too much protein. It's associated with a positive nitrogen balance. Its dietary nitrogen intake is greater than the excretion. Usually its most common causes this hemoconcentration and dehydration. One of its lesser common cause is multiple myeloma, and I'm going to show you a tube of that in just a second. The other way, hypoprotein, so not enough protein, causes a negative nitrogen balance. And its mostly common cause is the increase in plasma water. So here is some of the things we've talked about. Hyper, your number one cause is usually dehydration. So there's some other causes. Vomiting, diarrhea, that's going to make you dehydrated, so it's secondary cause to dehydration. Hyper, too much protein, this multiple myeloma, I'd like to show you a picture of a tube. So on the right here is a normal serum separator tube, and you'll see that gel separates the serum from the cells. But when you have multiple myeloma, that plasma or serum cannot fit through those gel. It cannot go through that gel because the protein is too big. The one time this happened to me, I thought I didn't turn the centrifuge on, so I spun it again and again, and you cannot get this to spin down. No matter how long you spin it, how fast you spin it, you're not going to be able to get that serum through there. And as you'll find out, this gel is very sticky, and it's nearly impossible to get down to that serum. And that was an interesting experience, so I hope you guys get to see that. But that is with multiple myeloma. So when you get a centrifuge, a tube out of the centrifuge that won't spin down, it's because it's very high serum total protein, and it also has a low albumin, and that's when you see that in a multiple myeloma. Here's some hypos. So your hypo is going to be not enough. Usually it's depletion. You don't have enough coming in. Massive IV infusion. Of course, you've got a lot of fluid coming in, but not enough protein. Burn patients, we talked about that. That will cause you to have hypoproteinemia. Trauma. There's some other malnutrition. That's another one. That's the intake, of course. Decreased synthesis, liver disease. Those are. All right, so our first methodology we want to talk about is this biurate method. This is your most common method. It's been around for a long time. It has to do with copper and the copper ions. So what this methodology is doing, it's measuring the bonds found in these proteins. So these peptide bonds that we learned, all proteins have these peptide bonds. They may be single bonded or double bonded, but they all have these peptide bonds. So what this method is doing, it's measuring those peptide bonds. So it's in this solution, and it's a copper-based method, and it's measured at 540 nm for the spectrophotometer. There's some more. This copper sulfate, that's that Cu ions, so be aware of that. Its main interference for this test, of course, is going to be hemolysis, because if you have a hemolyzed specimen, you're going to have disrupted red cells, and that is going to produce higher protein. Other causes for interference could be lipemia, bilirubin, and just a really dark turbidity. We actually have a lab over Biurate, and we'll be able to do this in person. Another less common refractometer, just the same that you would use specific gravity for urines. Same type of thing. It's a rapid approximate measure. It's not as accurate as, a quantitative measure, but it will tell you a higher protein concentration the greater the refractometer. So another method is going to be this dye binding method. So there's two types of dyes that you read at 595. Where is that? Sorry, thought it. Oh, that's with the albumin. Sorry, it's one. This blue G250. It's negatively charged, binds to positively charged protein molecules, because you remember from the very first section, proteins are negatively or positively charged. That will be important for electrophoresis. So get out your reference range sheet. Here's a reference range to add. So your TP is your total protein. That range is for adults is going to be 6.0 to 8.3 grams per deciliter. So please add that to your reference range sheet. And for your calculation sheet, there's an AG ratio that is calculated. It is the globulin, because there's two types of protein. There's albumin and globulins, right? The two different classes. So if you measure a total protein and then you measure albumin, with subtracting the two, you can get your globulin count. So that is what that AG ratio is, albumin globulin ratio. So please write that down in your calculation book. A low anon gap, or AG ratio, sorry, not anon gap, AG ratio can be found in the overproduction of globulins. So for example, that multiple myeloma, you're going to see a low AG ratio. For high AG ratios, you're going to have an underproduction. So it's kind of the opposite effect. A low AG ratio is going to have lots of protein, and a high AG ratio is going to have low globulins. Another way to measure proteins is through the urine. So urines originate mostly from the blood and are filtered through those kidneys. So they should not be filtering through into your urine and being secreted. They should be reabsorbing, right? So if you have protein in your urine, that would be abnormal. The most common method for screening urinary proteins is with your urine reagent dipsticks that you learned in urinalysis. I'm not going to make you memorize that. Just know that that is a cheap, easy, quick test that you can screen for protein in your urine. It's also a semi-quantitative analysis, so it gives you a +1, +2, +3, and a negative. So semi-quantitative, it doesn't actually give you a number, just quantitates an amount. Another way or a sample that you could run protein on is spinal fluid. Most of the time when you get a spinal fluid in the lab, chemistry has the order for glucose and protein. So for the protein amount for spinal fluid, the reference range is 15 to 45. So please write that down in your reference range notes. Increased levels of proteins are found in various types of meningitis, infections, hemorrhages, tumors, multiple sclerosis. So it's not necessarily weeding one thing down, but if they suspect an infection, then you're going to have an increased protein. And that's if it's not a bloody tap. Sometimes you're going to come across bloody taps. You're going to have to spin them down. And of course, you're going to have a really high increase because of that blood interference. And on those, you're just going to have to tag them on the report saying specimen was bloody or a bloody tap. So back to albumins. We're going to talk about albumin methodologies. So just to recap, albumins do count for 60% of your serum proteins. You can have hyper and hypo. So when we talked about some of the different diagnoses for that, of course, hyperalbuminuria, the biggest significant is your dehydration. And then hypo, not enough, is going to be tissue damage, inflammation, things like that. So there's two different dyes. There's a methodology that's binding with those anionic dyes. So you've got the green and the purple, so BCG and then BCP. Those are two main of the methodologies that bind protein. What I want you to know about albumin, the little cartridges and flexes that we put on the machine are very brown. So anytime you load an albumin flex, you'll know because that fluid is really like a dark, almost like a bile type of brown. It's like bilirubin-y color. The reference range for the albumins, if you want to add this to your reference range list, is 3.4 to 5.0 grams per deciliter. And there are four main requirements for dye binding methods. It has to be specific binding of the dye to albumin, high binding affinity between the dye and the albumin, substantial shift in the absorption wavelength, and then the absorption maximum for the bound form at a wavelength distinct from those where bilirubin and hemoglobin. All right, so our last method that we're going to talk about and just spend a few more minutes on is this protein electrophoresis. So we've been talking about this a little bit as we go. I want to show you our chart that we talked about earlier. So the protein electrophoresis is a migration of charged solvents or particles in this liquid medium under the influence of an electrical field. So depending on your protein, if it's positively, negatively charged, it's going to migrate on this paper. One end of the paper will go in negative, the other end will go in positive. I've included a YouTube video, so please watch that, and it kind of gives you a visual of this. The buffer solution is a pH of 8.6. So just keep that in mind. That is relatively a very high pH. It's not neutral body pH. It is a little bit higher. And it's a constant current and voltage that is applied for about 40 to 60 minutes. So the migration distance of these proteins, it varies with the charge carried by the protein. So here are some normal and abnormal that I wanted you to focus on. So you can see that there's 5 measurement areas. So it goes from albumin is the first one on the left, alpha 1, alpha 2, then beta, and then gamma. So you can see the little abnormalities. Down here, bottom left, is your multiple myeloma. So that is where that serum wouldn't go through the gel because the high proteins. There's your high spike of proteins. All right. Here is another picture more detailed picture of where those proteins fall on your electrophoresis. I don't expect you to memorize this. I just thought this was interesting. And this is a very difficult and specialized test. You don't normally see this in a hospital lab. You're going to see this more in a specialty place, you know, because it takes somebody with a lot of experience and a lot of schooling to read these and turn out these reports. And usually they're pathologists that look over the electrophoresis and makes the diagnosis. So this is just a summary, kind of what I said about the migration. Here's some more detailed information you can read on the PowerPoint. Remember that there are 5 bands. You'll need to know all 5 of them and what order they're in from left to right, starting with albumin. And there's a list of them with their relatively percent. So you can see albumin is going to have the biggest spike, where your gamma globulins are going to have the next biggest spike, and then the 3 in the middle. So fusion of the beta Y bands, it's just some more information about liver disease, necrotic syndrome. There's your acute phase reaction. We've already gone over this, but here's a good summary. So you're going to have an increase in your alpha 1, alpha 2, okay? And there's your acute phase reaction. Remember, your acute phase reaction is APR, and it increases with these situations, infections. We've talked about most of these. Tumor, surgery, burns. There's that burns. There's your MI. We talked about that. And this is a wrap-up of your electrophoresis pattern. Here's some abnormals, just some closer look at them. In the PowerPoint, here's that acute phase reactant. And there's your multiple myeloma. And that is it, you guys. All right, good job. Study the questions at the end of your chapter and go over your key points and checkpoints throughout the chapter, and you guys will be in great shape.